In this question, you've been given 2 points and you're asked to find the midpoint, M, between those 2 points, A and B. So this is where you can use vectors to help you out. So a good idea would be to actually draw or imagine, and we'll just do it this way, imagine an origin point, okay, so that would be the middle of your axes, that would be O. We want to draw one vector out to A. The point A is here in space. It's at 2, -4, 5. So in the I, J and K directions, we can actually write this as a vector. So we've imagined that we've got A as a vector, which would be going 2 across in the I direction, 4 down in the J direction, and 5 up in the K direction. Okay. The other point we've got is B. So the point B is given by 5, 1, 7. Okay. And if we wanted to look at what that is as a vector, that's the point B. I'll actually show where the points are. Again, it's the same thing. We can imagine going across 5 in the I direction, so I'm turning it into a vector, up 1 in the J direction, and then up 7 in the K direction, because they're all positives. They're all positives and they're all up or across. So we've now got vectors that represent these points in space. Now the other thing that I want to do with this is to actually consider, I'm just going to move this over a bit. Okay. Actually consider what happens when we move between those 2 points. So there's A and there's B. And now we've called this vector A, we've called this vector B. Okay. We want to find the midpoint of AB. So if we're thinking about AB, it makes sense to then think about AB as a vector. So we're actually going to try and find the vector A to B, which will then help us to find M, which is the midpoint. And the midpoint between A and B would be the midpoint of that vector AB. Okay, so when we look at this, you can see that you're going to have to go backwards along this vector, and I'll do the path in red so you can follow it. So to go from A to B, we'd have to go backwards along this vector and then positive direction along that vector. So we'd actually be writing our vector A to B as going backwards along this vector here, okay, which is, we'll write it as A to O, and then along this vector here, which is O to B. Now, something that you may have noticed at this point here, I called this vector A, I just gave it an A with an under tilde. You could also express this here as just OA, because you're going from the origin to A, which means that this vector B here is actually from the origin to B, OB. So now we can think, okay, well, A to O, that's backwards what this is. It's going backwards from O to A. So we'd go negative O to A plus O to B. So what you're going to be doing is you're actually going to be working on all of these values here for A will be negative, because we're going backwards. We have to go backwards along this vector first to get to that B. Okay, so a nice way of remembering this is if you're going from an A to a B, or from one vector to another vector, one point to another point, make all of the numbers in the first point negative and then add them to the second point, because that's what actually happens. You have to go backwards along this vector. So let's do the negative of this vector OA. So we're going backwards along here, so this will be negative 2i plus 4j, because remember we're going backwards, so everything's negative, minus 5k. So that's that part there, going backwards. And then the O to B, we just add that all on. So that's going to be 5i plus j plus 7k. Okay, so again, all I'm going to do is just look at factoring the i's together. So it will be negative 2 plus 5 in the i's. In the j's, it will be 4 plus 1. And in the k's, it will be negative 5 plus 7. And see, now you can see more clearly. Check it out. In here with the i's, see how it's the opposite sign of the 2 plus the 5? And then it's the opposite sign of the negative 4 plus the 1. So it's positive 4 plus 1. And then negative 5 plus 7. So you can straight away get from points to a position vector, A to B, by doing that shortcut. Just always making the first one negative. So it's a nice kind of rule, and I'll actually write that here so you can have that in your notes. For AB, it's always going to be that first vector, which we'd call O to A, and I've just called it A. It's negative A plus B, okay? Or negative O to A plus O to B. That's just a really nice rule that you can remember. You can use that as a shortcut so you don't have to go through that step every time. So now we actually know A to B, so therefore A to B is 3i plus 5j plus 2k. Now to go back to the midpoint, we know what A to B is. I'm just going to get rid of this part here because we've already found A to B. So let's have a look again. I'm going to just draw on our diagram here. This is our midpoint. This would be M, so that's halfway along A and B. So let's use again the red just to identify what we need to build here or use. So we want to know what halfway along or the midpoint of A to B is. So we could do this a couple of ways. I'm actually going to go this way. Oh, actually, no, it's probably easier. We'll go this way and then this way. Okay. So that's going to help us find this vector here. So we're interested in, and I'll do that in a different color, we're interested in that vector O to M, so we can find that midpoint, okay, of AB. So we're going to look for O to M, and I'll put that together now. So we've got O to M equals, and you can see we've got O to A plus, this is a midpoint, so it's halfway along A to M. And because we now know, A to B. We now know what A to B is, we can actually use that information. So we've got O to A, which we've got here, 2i minus 4j plus 5k. And then we've got a half of this vector, A to B, plus 2k. And again, one of those situations where it makes sense to isolate the i's. So you've got 2 plus 3 over 2, and the j's, which would be negative 4 plus 5 over 2, and the k's, which would be 5, 2 over 2 is 1, which is good. That actually works out nicely. So 3 over 2 plus 2 over 2, so that 2 is 4 over 2, so you'd have 7 over 2i. Here, this would be negative 8 over 2 for 4. Negative 8 plus 3 is negative 3 over 2, so we'd have negative 3 over 2j. And then for k, we'd have 6k. So O to M can be given by 7 over 2i minus 3 over 2j plus 6k. Remember, this is not asking you to find a vector, it's asking you to find the midpoint. Now see here the way that we went between points and vectors. This was the vector from O to A. It was given with the ij's and k's, but see how it's actually just the points in front of an ij and k? Same with the B. You can go between them very easily. It's just the points in front of an ij and k. So to actually give the midpoint for this question, the midpoint M, we can just go backwards the other way. So remove the ij's and k's. So we just have the x component, the y component, and the j component. So the midpoint in space for M is given by 7 over 2 in the x, minus 3 over 2 in the y, and 6 in the z. So the key things here is really identifying when you're working with points or when you're working with vectors, the difference between them. Construct a vector from the origin, a defined origin point to your point as O to A, or just giving it the vector A. And then also using this relationship here for position vectors. If you're going from A to B, it's always negative the first one plus the second one, and that will give you then an easy way to get the position vector. And then going backwards, if you've got a vector in space, which is from the origin, to get the actual point in space for M here, we just got rid of the ij and k and used the x, y, and z coordinates.